Good afternoon, everyone. So I'm Puneet Srivastava, Managing Director of Signaling and Infrastructure Business in Alstom, India. So before I start, I hope you all have traveled in the trains. Yes, you have traveled on the metros. So I just want to understand from you, do you understand what is signaling? Have you heard the word of signaling in rail industry? Anyone can just, if any heard the word of signaling, or what do you mean by signaling in railway industry? So make it very clear, signaling is basically the heart and the brain of us train operations. When you are sitting on a train, when the trains are moving, the safety, the reliability, availability of the train operations is decided or determined by the signaling system. It is a backbone of the whole system. You have seen the trains, you have seen the stations, you have seen the buildings, you have seen the other infrastructure, which is visible. Signaling is behind the system. It is a complex hardware and software which runs behind which ensures that the trains are running smoothly, trains are running on time, and you can get a proper information. It helps you carry the passengers from one place to other on a safe and reliable mode. Like when you, on the stations, you see the trains are coming in 1 minute or 2 minutes, or trains are delayed by a minute or so, then you can plan a journey. All these things, all this information which is displayed to you, all of you, is through the signaling system. So that is what we are doing in Alstom. Alstom is the leader of rail transportation globally, and we are in the signaling business. We are doing this system, ensuring that we run the train reliable and smoothly. To start with, I just want to give a big background what we do in Alstom. Alstom is a rail manufacturing company, as you all know, and a lot of challenges we are facing these days, or the rail industry. One is regarding the environmental, because climate change, and a lot of focus is there on the green environment, the green zero emission mobility. Then there's a lot of geopolitical and macroeconomics, which resulting into optimization and efficiency improvement or cost optimization. The third part is the population. You know, a lot of urbanization is taking place, and to cater those needs of urbanization and the migration of people, the best mode of transport is rail transportation. And we are seeing, especially in all parts of the world, especially in India, all Tier 2 cities are coming up with the metros. And this is just to decongestion the major cities. And then we also have connecting from the Tier 2 cities or the satellite towns to the main cities. Like we have Namo Bharat, Delhi-Meerut connectivity is there, and this is coming out very fast in the country. So all these challenges which we are facing, all are addressed by Alstom. We are addressing it. We are helping in providing a zero-emission solution. We are helping in providing an optimization and efficient solution. And finally, we are designing a solution which is meet the demand on a larger scale. So this is what we are doing at Alstom. We create a mobility solution that offers enjoyable travel experiences and drives societies towards a low-carbon future. That is what Alstom is doing. We are manufacturing trains. We are doing a signaling system. We provide a complete solution so that the trains are running smoothly. So we manufacture trains not for the long-distance trains and for the metros, which is within the cities, which is called urban rolling stock. We manufacture long-distance intercity trains, which is mainline trains. We manufacture locomotives. We do components, which goes in behind these locomotives and the trains. Then we do the signaling. As I just told you, it is a heart of the train operations. It's reliable and available, which ensures reliability and safety for the train operations. And then we do our infrastructure, and provide the services. In all this, we are using a lot of AI. So people wonder how AI can be used in the rail infrastructure. But in order to have a better, smooth operations, in order to have a better, reliable system, a lot of data science and AI is being used. So I'll be sharing the few use cases and the work we have been doing in AI in Alstom. And this is all is done in Bangalore. In fact, Alstom is one of the biggest R&D and design center in India, in Bangalore. And all this thing is driven by the Bangalore team sitting here in our office and driving for all the work we are doing across the globe for Alstom. So how AI is helping in various sectors? As I just told you, rolling stock is basically the train. It is helping in improving the reliability of the train It is helping in reducing the energy consumption. For signaling system, it is helping in reducing the downtime, which improves the availability of the system. It is helping in driving the energy efficient solution. Quality, definitely, it is helping in availability and troubleshooting. And finally, we are helping in overall cost to the deployment, at the maintenance cost, and the various inspection level intervals which goes behind. Because a lot of predictive maintenance, a lot of analytics is being done to ensure that the trains are running smoothly and reliably. So we have a huge data. When the train runs, data is there. The train data is there. The operation side, data is there everywhere. How, and it, in fact, really see when the train runs for a few kilometers, thousands of byte data comes out here every second, and it is stored in various places. So if you really try to do the manual analysis, it's really challenging. And that has been a challenge in the past, where the manual analysis was done. There's some automation was brought into the system. But now, with the help of AI, we are able to capture the data. Basically, we are able to get all this data which is there, whether it is from the energy perspective, from the signaling perspective, or train perspective. Then we also capture the data for the passenger, which is on the stations, the ticketing, which is coming out here, the operations, the security, CCTV, and all this journey data. So all this data is there. And what we do is, now we are using AI to analyze this data, to use it for the better operations. And this, we are passing on the information for our purpose, for better maintenance, or for better reliability, or we are passing to the operators for better operation of the train. So this is a very simple diagram of a train. So when the trains are running, this is not seen to any passenger, basically, just to let you know. The passengers comes and sits inside the train, but a lot of computation goes behind it to ensure that the passengers are carried safely from one place to other. So we have collect a lot of data, whether it is from the speed perspective. We have the batteries, we collect the data, a lot of how the current is being captured by the train from the overheads, how the doors are being done, what are the wheel defects coming out here, any sparks coming out here, the air conditioning and ventilation, which is inside the train. So a lot of data is being collected. So we use this data for dynamic maintenance planning. If any trend is we find, so we make a planning for the maintenance, which any particular equipment requires to be changed, or any condition-based monitoring to be done. Or it also helps in predicting any equipment is going to fail, and it really helps in improving the reliability of the system. Similarly, for this you see trains, basically from the signaling perspective, the signaling, as I was telling you, is a core of the train operations. We have a lot of information is shared by the radio. By the one train shares the information to the other train via radio through various equipments which are installed in the station. Then, so all this, then a lot of trains are running. If you really see in a network of around 20 kilometers, approximately 30, 40 trains are running at a time. This means a lot of information is there, and we collect this information, we do the analysis, we do the diagnostics, and we are helping in making the train run reliably. So now I will going to share you some few use cases, how Alstom has been taking the lead through AI in leading this basically diagnostics, and also helping our operators across the globe in providing a reliable solution. So one of the core part of our train operation is the radio. When the trains are running, it is passing information from one place to other to our radio. Radio is simply a wireless network, which there's some radio equipment installed at the wayside on the train. And suppose anything goes wrong in the radio, there's a huge loss of communication, and train will stop. It is a really catastrophe. If your radio of a network is off, it means approximately 15, 20 trains are stopped at a location, and the passenger sitting out there will not be able to go to their desired location, or the passenger who wants to come, they'll be just waiting for the trains. So we have developed a solution. It is a solution in-house, done in India. And so earlier what was happening was, it was a huge challenge in collecting a data, analyzing a data, and then because it is a manual exercise, it was taking a lot of time, and finally when the train stops, it is a huge penalty which operators imposes on any OEMs, and there's a huge challenge was there for us also. So we came out with a solution with the help of AI, where we collect the radio measurements, the various parameters of the radio on a real-time basis. It is collected, it is stored, and it is diagnosed on a real-time basis. So if anything is going wrong anywhere in the network, immediately, either if any parameters need to be corrected, automatically the information is being done, or any preventive action needs to be taken, information is passed on to the maintenance team, and they are able to attend the issues immediately. So basically, this has really helped in improving the reliability. Now we have deployed in few solutions in Europe. Solution has been developed from India, but we have deployed in Europe, and it is really working fine. And we have a feedback that the train operation have really improved after this deployment of this solution. And now we are going to scale up across the globe, basically. And since it is a more proactive way of analysis, it is really helping the operators also. So as I just told, it is a continuously monitored, and all the issues are automatically detected and diagnosed. And any corrections which are there, it is automatically produced. Suppose there is an issue in the network, in the radio, immediately the information is being passed on, a correction is being done without any manual intervention. And if manual interventions are required, messages goes to the corrective maintenance person, and he takes the corrective action immediately. So this is one of the things which has been really helpful. The AI has been helping us to improving the reliability of the train operations. The other important aspect of where we are using AI is in our predictive maintenance for infrastructure. I hope you must have seen the rail network, the tracks, and how the train moves basically from one place to other. It is not like a car where the driver is sitting and is maneuvering the steering wheel. There are tracks which move from one point to other, and which drives the train to that direction. So how it is done normally? Machines are installed on the track. If you really see, these are some machines are installed on the track, which moves the track so that the train can move in the desired direction. It is a very sturdy equipment installed on the track across the world. The same principles are there. And if anything goes wrong, this means the train has to halt and person has to be sent to the site to attend it. There's a huge tedious exercise, huge manual exercise. And frankly speaking, this is a isolated equipment installed at site. It is having going through all the heat and weather conditions. And if anything goes wrong, it is a really tedious exercise. That means you have to stop all the trains in the network, send some person to site if anything wrongs happen. This was a huge problem which was there. So what we have done is we have used the AI in predicting the failure of this equipment, which is installed at site. Earlier, as I just told you, there were a lot of manual inspection was done, and it was a really pure manual exercise. Then we went through a threshold-based analysis. Some parameters like current or voltage is going beyond a certain limit. It expects that equipment will fail. Now we have gone with the AI-based. We monitor a lot of parameters which goes on during the operation of this machine. It is monitored on a real-time basis, and we are really So basically, we have developed algorithms, AI algorithms, which clearly monitors the parameters, which is used for the this machine operations. We monitor the trend of those parameters, and based on the trends, our AI tool is able to predict the equipment is going to fail, and that has really helped us a lot in the train operations. Whether it is a friction, whether it is a power supply, or when it is obstacle on the station, it can be predicted. So we have basically we have a complete anomaly detector is installed, and our AI is able to classify them into various classification based on what is going to they can also predict what is the reason behind that failure, and then you can predict whether any correction needs to be done. So this has really helped in our train operations. It has really helped in improving the operations time. So as I just told you, a lot of parameters are being measured on a continuous basis. And suppose any obstacle is there, certain parameters, there's a slight spikes in the parameter. The AI monitors it, measures it. There's some obstacle at the site. Immediately a message goes to the maintainer who is there at site. He'll just go out and have a look into it and get it removed. So before any train comes to into this track, or before any operation takes place, we come to know there's some issue, and it can be attended without stopping the train and ensuring that the trains are running on time. And this is a solution we have deployed, which is not specific to any particular machine. Across, there are various manufacturers of point machines in the world. So this is scalable to different type of machines, and this solution was developed by Alstom, but it can be used by any of the machines used for track by any of the vendors. The other aspect of AI we are using is smart and faster log analysis. So the core of our safety, core of reliability, lies in we have a central computer which computes all the information which is there. It has all the information of the train speed, train length, and all the information which is there required to run the train smoothly and reliability. So it's a central computer which is stored in the stations, and it has a track of, it monitors all the train in the system. If anything goes wrong in this system, and there's logs are there, and there's huge logs are there, because it records each and every event, and to read those logs, to understand those logs, it's a huge tedious exercise. A lot of logs are coming in thousands of lines logs comes in a per minute basis. To understand those logs, to analyze those logs is a really tedious exercise. Now we have used AI to understand these logs, to analyze those logs. First of all, we are collecting the data for all the logs which is coming out here. We have developed algorithms. Then most important part is we are able to do the root cause analysis. And that is really helping it out for our system, for our maintenance perspective, and also from the operator perspective. Because trains are, now we are able to identify the issues, identify the anomalies which is coming out because of these logs. And finally, we are able to do generate the reports and also take the corrective actions. So just to give a very briefly, suppose for a single issue, we were taking approximately 8 hours of work. 8 hours just to analyze the log. Forget about resolving the issue. Now we are able to get it in less than 1 hour, and with the help of AI. This is still in the process, and as we know, as we keep on training the tool, it becomes more predictive, more analytic. So I'm pretty sure it will be done in a few minutes. The understanding of those logs, which was taking hours or days, it will be done in a few minutes. And that is really going to help in taking fast decisions, removing the cost of operations, and also boosting the mean time to repair. One of the KPIs which operators always monitor is how much time it takes to repair. So definitely, because we are able to understand the issues much earlier, we have been able to reduce the mean time to repair, and finally, definitely is going to improve the customer satisfaction. Last, this use case about the energy saving. And we all know how the cost of energy is increasing on a day-to-day basis. And all the trains which is running across the globe are either running through electricity taken from various sources, and the cost is really increasing. And one of the biggest challenge of operators is how to reduce the cost of energy while running the trains. There are various methods which have been deployed in the past. Some are manual, some are more operator-driven. But finally, these methods has not been resulting in a better energy optimization. So Alstom has come up with a solution where we have optimized energy savings. In fact, we take the measurement, take the parameters of all the trains which are in the system, and we give a command to a train of which speed they have to accelerate, which speed they have to decelerate, so the current consumption which is there for the train is optimized. and ultimately optimizing the energy. This solution which we have deployed, we have a solution where the trains are running without the drivers. So our solution is basically monitoring the train parameters, train speed, and we are giving a command to the trains, how to run the train, how to, in which speed they have to run, and where acceleration has to be done. And so that, first of all, it doesn't affect the passengers, and also helps in optimizing the energy consumption for the operators. So basically, we have been able to save more than 15 to 20% of the energy, recovering of the energy by our solution, and that has really helped. So the benefits, as I told you, it is benefit to all operators, all metro cars, without any additional infrastructure investment, because this is a solution we're working on back end, and this is really helping, and finally improving the operational performance. So finally, before we close, just I want to show we are the leaders of rail operation, global leaders in rail manufacturing, helping enhancing the railway operations, and finally with the help of artificial intelligence. And that is Alstom has been doing. We are the leaders across the globe. And this Bangalore team, which is sitting in India, around 4,000 people, we are working out here, working and helping the rail operators to better radio monitoring, infrastructure, or health management, and dynamic maintenance. And this all is going on through with the help of AI. That's all. Any questions or anything is there?